So this OChem problem says all the structures shown here have the same molecular formula, CaH18. Which structures are the same molecule? And the hint is very helpful here. The hint says one way to answer this question is to determine the chemical name for each structure. So, personally, I find this way of writing out the chemical formula pretty messy when I'm trying to name a compound. So I prefer to name compounds when they're in stick structures. So the first thing that I do is go ahead and draw out the stick structure. So if we'll look across here, you have 1, 2, 3, 4, 5 carbons. So this is going to be A. Oops. I'm going to have 1, 2, 3, 4, 5. So you see 1, 2, 3, 4, 5. And off the second one, you're going to have a methyl off each one. And then off the fourth one, you're going to have a methyl. So now, let's do B. So you'll see we have 1, 2, 3, 4. 1, 2, 3, 4 there. And off the second one, we have a methyl. Off the third carbon, we have an ethyl, which is 2 carbons. And off the fourth carbon, we have a methyl. And by the way, I'm looking at them from left to right. So when I'm referencing the fourth carbon, I'm talking about the fourth carbon from the left-hand side. So down to C, we have 1, 2, 3, 4 carbons straight across. On the second carbon, we have a methyl hanging off. And on the third carbon, we have a butyl group. I'm sorry, a isopropyl group. So a CH here, and then a CH3, and a CH3. So now for D, you have 1, 2, 3, 4. Off the second carbon, you have a methyl, and off the third carbon, you also have an isopropyl. Now, don't let that isopropyl fool you, because sometimes it might be in a different location. Don't just assume because 2 molecules have an isopropyl group, which is a little bit less common than a methyl group, that they're the same thing. We're going to have to go through the whole shebang to figure this out. So the first thing when we talk about naming alkanes, and this is an alkane because there's only CH bonds in this molecule, no CH double bond, or no, there's only carbon-carbon single bonds, no carbon-carbon double bonds or carbon-carbon triple bonds. So these are all alkanes. So when we name alkanes, we want to identify the longest carbon chain, also called the parent chain. Then we're going to want to identify any substituents, so any methyls, ethyls, isopropyls. Then we're going to number the carbons in the chain so that the substituents are on the carbons with the lowest number. So if you have 3 substituents on carbons 1, 3, and 5, you're going to want to make sure that those substituents end up on 1, 3, and 5. You want to make sure that they don't wind up on 2, 4, and 6. So the next thing you do when you name, you group identical substituents together. So for instance, we'll see that there's going to be a couple methyls, and then you're going to alphabetize the substituents, ignoring any prefixes. So an ethyl would go before a methyl. Isopropyl comes after methyl, by the way. So let's go ahead and get started. So for A, let's see, no matter how you slice it, I think you get 5 carbons. So 1, 2, 3, 4, 5. You can go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Any way that you go, you're going to get 5 carbons. So I'll go ahead and number them. So this is going to be a pentane. And you see that we have a methyl on 2. We have a 2,2-methyl and a 4-methyl. So, ideally, like I was talking about before with the fewest substituents, it would be wrong for this to be carbon number 2 and this to be carbon 4. Because you'd rather have 2,2,4 trimethyl rather than 2,4,4. So we'll go ahead and write the name out. So this is going to be 2, 2, 4. So these are basically just showing you which carbons these methyl groups are on. So numbers are separated by a comma, numbers and words are separated by a hyphen. So groups, one located at carbon 2, a second one located at carbon 2, and a third one located at carbon 4. And because this is a 5-carbon alkane, it becomes pentane. So the name of this molecule is 2,2,4-trimethylpentane. Let's go ahead over to compound B. So this one, 1, 2, 3, 4, 5 carbons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this one is again going to be a pentane. But when we name compounds, we want to make the fewest number of substituents. And if we go straight across this way, we're going to have a methyl and an ethyl. But if we go this way, that's going to leave us with an isopropyl group. So the best way to number this compound with the fewest number of substituents is going to be like this. And it doesn't matter if you go this way or this way, because the isopropyl is still going to be on carbon number 3. So this molecule is going to be called 3-isopropyl, identifying which carbon the isopropyl group is on, and then once again pentane. So that's going to be all one word, 3-isopropyl. So if you come down to C, let's count 1, 2, 3, 4, 5. 1, 2, 3, 4. No, 1, 2, 3, 4, 5. So it looks like either way we slice it, we're going to have 3 methyl groups here. So we'll go ahead and number them. We'll double check to make sure there's no other way to number that to make the lowest number of substituents. But either way, it still looks like the methyl substituents are going to be on carbons 2, 3, and 4. So very similar to A, this one has 3 methyl groups, so it's going to be a trimethyl. We'll identify which carbons these are on. So it's going to be on carbons 2, 3, and 4. You have trimethyl. And then since it is a 5-carbon alkane, it's going to be trimethylpentane. And finally D. C. 1, 2, 3, 4. Sorry. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. 5's already 1, so it can't be a butane. 1, 2, 3, 4, 5. So when you draw it out, this one actually kind of looks very similar to C. And in fact, when we number it, we'll see that it is again 2, 3, 4 trimethylpentane. So remember that these both had the isopropyl groups when we were drawing them hanging off one of the carbons. And I told you to be careful and not assume just because they had an isopropyl group, because B also had an isopropyl group. So it was really beneficial for this exercise to draw them out and then go through and name them all, because you actually see that C and D are the same. Whereas if you were identifying the isopropyl group, you might have accidentally thrown answer choice B in there. So the answer to this question is that molecules C and D are the same molecule, and they also have the same molecular formula.